So these kinds of things, I like to do them reasonably conversational. So if anybody is willing to have a brave volunteer chat back and forth, I think that's ideal. Otherwise, I can just talk as well. Um, Usually, another student who goes by the pen name Balance of Justice helps out a lot, and that we like to talk back and forth and discuss problems. But last quarter, we were doing these study guides, was basically just last minute panic for people who had exams the next day, and I would just go ahead and talk. So if anybody wants to volunteer, speak up now. Uh, and you can consider this almost like one-on-one tutoring.
Go through the first sections with you guys. The only one that I didn't get on the first one was D, just because I didn't have time and I just kind of skipped over because the other ones were easier.
Okay, let's take a look at D then. What is D? It says a cylinder centered on the x-axis containing a point Q. Alrighty then. So I'm going to draw my right-handed coordinate system, and I'm going to draw a pretty rough cylinder, yeah? But the idea is that it's centered on x, which basically means that x is going to be a free variable. So we're going to expect x not to show up in our final equation because it can essentially be anything. X is sort of unconstrained. So our equation for the cylinder is probably just going to look like some function c that depends only on y and z. Okay?
Yeah, because remember, like for an equation for sphere and an equation for a cylinder, since everyone typically knows like the equation of a sphere from other classes,
Mm-hmm.
pretty much just omit the variable that it is being centered about.
Exactly. Omits x. So all that this question is really asking you to do is okay. So it's centered on the uh, x-axis. So and then the point that we're given q, I'll just draw it like this, is equal to negative 1 comma 3 comma 0. Well, this is basically saying that this point here, the x value is unimportant because x is allowed to vary freely, sort of up and down the axis or up and down the surface of the cylinder. So this is basically saying that all that matters are the y and z components, 3 and 0. And if we drew this as a sort of one-dimensional cross-section, yeah, if you can imagine just drawing, taking a perpendicular plane through Q, kind of like this. It's very hard for me to draw perpendiculars, but imagine a perpendicular plane cutting through the cylinder right through Q, right? At this point, the x-axis disappeared because you're looking right onto it, and all that you see is a yz plane. YZ plane with a point Q that is 3 comma 0, right? Does everybody understand why this is the I guess it's not so much a projection as it is a one-dimensional as a slice, but pictorially, could you see how just we're kind of looking, if you look right on the cylinder, we would just see a circle? Does that make sense? And the reason I'm doing this is because it makes it extremely clear what our equation ought to be. If I told you, I told any, I think, 8th or ninth grader and asked them what's the equation of this circle, well, hopefully they would just tell me y squared plus z squared is equal to, well, the radius we know is 3, right? So that's going to be 3 squared. And the idea is that although this equation in 2D is a circle, what's up? Sorry, did someone say something? I'm happy to address it if there's any questions. Okay, maybe not. So y squared plus z squared is equal to c squared is the equation of a circle in 2 dimensions, but it also happens to double as the exact same equation for the cylinder in 3 dimensions. Basically, x is unconstrained. It doesn't even appear inside the equation, but just understand that this equation, when thought of in 3D, is a cylinder. Can you see why that is? A cylinder is really just like an infinite number of circles stacked on top of each other, right? Can you picture
And
that?
an interesting way to think about like a cylinder graphically is whatever it is centered on. If it's saying it's centered on a point, you have to kind of imagine it like a spike, and you're sticking the cylinder. dead center on that point, and it's going to run along that point or that center forever, unconstrained. So that's why you omit the cylinder. That's kind of like how it helps me like to visualize
So
it.
what do you mean a
That
spike? By the way, just to be clear, is everybody seeing my screen right now? I'm screen sharing through a second account. It's you should be able to click the live button. Just to make it very clear, I'm drawing right now on a Microsoft OneNote pen, so you should be able to see something. But what do you mean by a spike?
think of it like, so let's say the x-axis is the center.
Sure.
Admit that. That means we're going to slide the cylinder on to the x-axis. It is going to be dead center, aligned on the x-axis forever. It
Yes.
is the center point.
Mm-hmm.
So just to kind of visualize like that, that's kind of how I learned it, and it really helped me anytime I had a cylinder equation problem.
Oh, I see. So you're sort of saying like
Yeah.
the x-axis is sort of like the spike sticking through the middle of the cylinder.
Yes.
I see. Yeah. That's a good way to qualitatively describe it. It's if you think of the cylinder as a massive like log, right? The x-axis is basically just this it's basically just the very center of that log. But yeah, that covers question D.
Exactly, actually.
What's up?
A little block of wood and he just goes right on the center, right there.
Yeah. So yep, that's part D. Does anybody have any other specific questions they'd like to ask about this problem or others?
May I ask how we know that the point contained in the cylinder is on the farthest part of the cylinder? Because all it said was containing. Like, how would we know that 3 is the radius?
Okay, that's a really good
it was
question.
just in it.
Yeah, so this is because the question is slightly ambiguous, but it seems to be understood that we're talking about a cylindrical shell as opposed to like a solid cylinder, right? And you're actually making a really good point because their question is slightly ambiguous and kind of requires you to implicitly assume. Because like if this cylinder was like completely shaded in, right, and all you knew was that the point Q was like somewhere on the interior of it, well, then there's any number of cylinders with really, really big radii that would contain it. So it's kind of circular logic in that they expect you to understand that you're being asked about a cylindrical shell. Does that make sense? It's not the most satisfying answer, but it's just sort of understood to be the spirit of the problem.
Yeah, it's the only point they give us too, which would make sense. All right, thanks.
Yeah, of course. No, that's a really reasonable question, and that's why I like audience participation is stuff that would just sort of I would implicitly assume from experience. I think students seeing for the first time would naturally raise, well, a lot of natural questions. And I think that's great. And that's, the same goes for the other parts, like part E as well, the sphere centered at Q containing the point P. You probably have to assume that it's a spherical shell. Alrighty. Does anybody have other questions that they'd like to ask in particular, or shall I just run through them? Okay. Well, yeah, let's just see if we can quickly go through. So we're saying part A, the plane through P parallel to the XY plane. No, I always like to draw these out a little bit. But if the XY plane, XYZ, the XY plane is when Z is equal to 0, right? So something that's parallel, sorry, this was a really terrible XY plane. So anything that's parallel to the XY plane is going to be Z is equal to 1, Z is equal to 2, or 3, or 1.5, or Z is equal to something. But the idea is that where Z is constrained, X and Y are unconstrained. So the idea is that if we know that we're looking for a plane that's parallel and also includes the point P, which is just 2, 4, -3, that's sort of saying we don't really care about this value or this value. All that we care is the Z value, and that's for Z is equal to -3. So right there, then and there is your answer. Z is equal to -3 is the equation of this plane in particular. That's parallel to XY plane and also contains point P. Any questions about that?
There's an interesting section in the book from our first reading that gives you the formula and reasoning behind this too, and how to get to different planes too. But yeah, so I'll just throwing that out there for anyone who wants to study afterwards.
Yes. Question two, where's it? Question three will ask us how to generally find a equation of a plane given points, and we will cover that more generally because that involves a little bit of the cross product. Honestly, I don't think the questions are too involved. They just require you to be a little bit careful and remember your basic surfaces. But yeah, let's quickly go through them. So this next plane goes through Q, and it's perpendicular. This is a symbol I like to use for perpendicular. It's just sort of like an upside down T to the y-axis. So what is that saying? If it's perpendicular to the y-axis, x, y, and z, if it's perpendicular to the y-axis, like one example would then just be like plane xz, right? So again, it's kind of hard to draw in 2D, but just imagine like the xz plane is an example of something perpendicular to the y-axis. But it's very similar to part A. So if it's, for example, the xz plane is when y is equal to 0, then we're just looking for a point. We're looking for something similar with point Q, which is -1, 3, 0. So again, x and z are unconstrained, so we don't really care about them. All that matters is we get y right. So this is saying y is equal to 3, and then we're done. Hopefully that's pretty comfortable so far. And please, if you have questions, speak up. I'm, I do this because I enjoy it. I like taking questions too.
I had a question. So for the perpendicular to the y-axis, it would have to be y equals 3 just because point or like a plane that is perpendicular to the y-axis would have to through Q would have to share the same y coordinate, right? For them in order for them to be perpendicular, right?
Well, it's not that it's in order for it to be perpendicular. It's in order for it to contain, well,
Yeah.
in order to contain the point in question, assuming it's
Yeah.
already perpendicular.
Yeah.
Well, really it's both, right? But
Yeah. Okay. Let's just double checking. So if it says perpendicular to the y-axis going through Q, you just need to go locate Q and then figure out what point they would share.
yes, yes.
Okay.
Um, yeah, I wonder if I can make a more general statement or if I should hold off on that right now. But the idea here is that, how should I put it? When you have something like y is equal to like some c and you're trying to figure out what c is exactly, you should only need a single data point like q in order to tell you in order to fully specify what that c ought to be, right? There's only sort of one unknown in this situation, so one point should be sufficient to solve for it. And keep that in mind as we go on and talk about planes more generally. uh, Later on you'll see that in general we need 3 points to specify a 3D plane, and that's kind of analogous to your high school algebra, where do you remember how you would need 2 points to specify a line uh, in high school? It's kind of the extension of that. Okay, so let's keep moving. So the cylinder of radius 6 centered on the line through P parallel to the z-axis. Okay, so P, I'm just going to draw it off randomly somewhere. I don't really care where. But if this is x, y, and z, it's basically saying, okay, you've got this thing going through parallel to the z-axis, and yeah, all you know about it is that it's this thing right here. It contains the point in question. So, excuse me. The fact that we know that it's parallel to the z-axis means that z is the unconstrained one. So this basically means that we just need to make sure that the x and y match. Maybe match is the wrong word. We basically need to make sure to find the right values of x and y. And again, the equation for a cylinder is going to look like x minus x naught squared plus y minus y naught squared is equal to r squared. And we're going to know that r is equal to 6. Right? This is just the equation of a cylinder in 3 dimensions, which is the same as the equation of a circle in 1 dimension. So at this point, we basically just need to go in and what was our point? Was it point P? Yeah, so P was equal to 2, comma 4, comma -3. And well, this right here and this right here are your x naught and y naught. So if you plug those in, you're done. And that's your equation. But what the math is actually saying is that, okay, the -3 doesn't really matter. All that we care about this point is sort of its x and y coordinates, which are 2, I guess x is equal to 2 and y is equal to 4. And the idea is that if we just if we plug that information in to the equation of a cylinder, we're done. So this is something that seems fairly simple to me because I'm relatively experienced. But if this is confusing at all, speak up. I'm wondering if I'm trying to it would be over explaining to try to talk about the circle analogy again from lower dimensions. Are we all set to move on, or do we feel
this makes sense to me, but
okay?
I was actually curious if you could briefly talk about, like, geometrically, what does it mean for something to be unconstrained?
Yeah, something to be unconstrained. That's a good question, and something that I was how do you put it? It's always a very good thing to ask about something I gloss over, like using the word unconstrained. Um, but the idea here is that, for example, in this equation, you don't see z at all, right? This is your final answer, but z is not in here whatsoever. So mathematically, or I guess I should say quantitatively, this is saying, whenever you have a valid solution, like x is equal to 2 and y is equal to 4, I could say uh, z is equal to 5 is a valid solution. 2, 4, 5 is valid. And I could say z is, 100 is valid, or z is pi is all valid. And that's just corresponding to, sorry, I shouldn't be saying, excuse me, hold on a sec. Yeah, sorry, I shouldn't have been using 2 and 4 there because that's talking about the center. No, the point is, let's say that you explicitly go through and find some points out here. And to make things concrete, if the radius is 6, and let's say that this is x is equal to 2 and y is equal to 8, right? So the points 2, 8, anything is going to be an explicit solution to this equation right here. Yeah? And you should be able to, so when this is 2 and that's 4, did I get that backwards? Sorry, I may have gotten this a little bit backwards. Did we say that P was 2? Right, so I should have probably, sorry, Y has to be 10, a mistake. So, but you can see right here that this literally satisfies the equation, right? 2 minus 2 is 0 squared. 10 minus 4 is 6 squared, and this just turns into 6 squared is equal to 6 squared. And that's a valid solution to the equation. But the idea here is that z doesn't affect anything at all in this equation right here, which is saying that the point down here could work, but the point directly above it or the point directly below it, works as well. And it's basically saying that this forms a cylinder because for every point you have on the circle, everything above it or below it also works. And similarly, for a point over here, anything above it or below it also works as a solution to this equation. Does that explain your question?
Yes, yeah, I can understand
Yeah, sorry for stumbling in the arithmetic. You find that the further you go in math, the worse you are at actually adding numbers together.
it.
Um,
We appreciate you.
yeah. Okay. So if we're all set to move on, let's take a look at E real quick. The sphere centered at Q containing, so, to be clear, this was our explicit answer to the last one. The extra stuff was talking about what it means to be unconstrained, how the math for being unconstrained correlates to the actual geometric picture of being unconstrained. But yeah, we already did D, so if you want to watch it, go back to the recording. But for E, it's asking this sphere centered at Q containing the point P. So I don't think we even need to necessarily draw the coordinate axis anymore, but this is understood to mean that P is sort of lying in the shell. So at this point, what this is asking us to do is the general equation for a sphere is x minus x naught squared plus y minus y naught squared plus z minus z naught squared, right? And that's going to be equal to r squared. And in this particular case, this is the center of the sphere, which is understood to be Q. So what value did we have for Q? It's -1, 3, 0. So we're literally just plugging that in, literally just plugging those numbers in. And the only thing that this question is really asking us to do is to figure out what R is, right? But R is literally just the distance between Q and P. So we ought to be able to just do a little bit of distance formula to be able to figure out what that is. And I'll do it explicitly for computation because this is for the sake of review. But as a reminder, the distance formula is the square root of the squares of the component-wise differences. So this is reminding us P is equal to 2, 4, -3. So this turns into 2 minus -1 plus 1 squared plus 4 minus 3 squared plus -3 minus 0 squared. And I'm not going to do it explicitly, but I believe this comes out to be square root of 19. So then R squared just becomes 19. And that's that. Feeling good so far? Like a lot of this stuff. What's up?
Oh, I do this in a different way.
Sure.
So because it's centered at Q, that means Q has to be A, B, and C, because A, B, and C represent the center on equation of a sphere. And then I put any X, Y, and Z in there. And since I know P is a point on there, I could put in 2, 4, and -3 as X, Y, and Z. So if you just build the equation and you just do the math for it, it actually gives you n equals R squared.
Yeah.
So if you don't want to do this formula, you can just literally plug everything in and get your R squared and you're good.
Do you realize that you literally just described the distance formula? Like, I agree that it's conceptually a different approach, but look at how similar the distance formula is to the equation of a sphere. Do you see that?
Yeah.
The only difference is that instead of calculating R, you're calculating R squared directly.
Yeah.
You see that? Like what's up?
I said just for I don't know why, but just for me, being able to plug things in
I
and
see.
then kind of visualize it that way, it's always a lot.
Yeah, no, I definitely think that yours is a valid approach, and conceptually, it's a little bit different. I just wanted to highlight the mathematically, you're doing almost the exact same thing because it comes down to the circle being defined. Sorry, it comes down to the sphere being defined as the set of all points that's r distance away from a center.
Yeah.
Right.
And
the relationship between the Euclidean distance and the sphere is pretty much by definition, I think.
yeah, and just remember, guys, that A, B, and C, what this means in the equation, it's representing the center.
Yes. So basically, what's happened there, your way was basically plugging in the values of Q with the arrows I've already drawn and plugging in the values of P like this. And it works out to be the exact same thing. But yeah, I think that's a really good way to be able to think about, it's really good to be able to think about things in slightly different ways. Happy you brought that up.
I just want to throw something in if I can.
Sure.
It's just again going with what you guys were talking about. Another alternative way of solving it. You basically take the magnitude of the vector from Q to P, and it's the same exact equation.
Yeah, that's taking the vector. Excuse me, taking the magnitude of the vector between Q and P. Again, is another way to think about it that ends up being mathematically almost identical. Because the vector between Q and P just turns into, what is this? 2 plus 1, 4 plus 3, 4 minus 3, and -3 minus 0. And then doing the magnitude is just the square root of all the squares, right? But oh, look, that's exactly what we had over there. right? So yeah,
Yeah.
all are perfectly valid ways to think about pretty much the exact same thing. And the good thing about math is you basically only need to figure out one way to do it on a test, right? But for a review session, I think it's really, really good to figure out all the different ways to think about it, different and equivalent ways to think about it. Okay, ready to move on to the last one about the circle? The last one I won't probably compute out in full detail, but it's basically saying what is this, F? It's basically saying, okay, you got a sphere, and it's saying that at opposite ends, one is P and one is Q. So to figure out again, we're going to be using the x minus x naught, this equation. And this time it requires just a tiny bit of calculation to figure out what x naught, y naught, and z naught are, right? X naught, y naught, and z naught is the center. And to calculate it, you can just add p and q up and divide by 2. You just average them together, right? Alternatively, you could figure out what, so maybe I'll call this C for center. So C you could find by adding, treating P as Q as coordinates and just adding them up and dividing by 2, each component wise. Or if you wanted to think about it in vectors, you could think about a vector, you could maybe think about a vector V that goes from P to Q, and then just add P plus 1/2 V in order to get the center. I'm sure there are probably other ways to think about it as well, but hopefully it shouldn't be too bad to find the center of the sphere given 2 points that are diametrically opposed. But at that point, once you have x naught, y naught, and z naught, you plug those in, and all you have to do left is to find the radius, right? All you have to do left is to find the radius. And again, you can do that in any number of ways. You could take the center and you could just figure out how far it is from Q or how far it is from P using the distance formula. And then you're done. And you know that the answer comes out to, I believe, 19/4, whereas the previous problem, r squared was just 19. This is because the radius is halved, so then r squared becomes quartered. So this is just a really nice sanity check compared to the previous problem. Does that make sense?
So we just use the distance formula, but this time relating the center to either end to find the radius.
Yeah, that's a perfectly reasonable way to do it. So just to write it out in a tiny bit more detail, you would say r would be equal to, sorry, I forget exactly what qx minus x naught, where x naught is the specific values of the center of the circle, squared plus y minus y naught squared, etc. for z, right? This is just the distance formula. Oh, by the way, definitely know the distance formula by heart, right? It's I know that not every student is maybe necessarily fresh in math, but this is one of the things you got to know down stat. I mhm.
Also notice that this is, if it's saying P and Q are at opposite ends, you just need to do the midpoint formula, which is what exactly we did at the very first step right there.
Yep.
So I don't know if you guys just recognize that off the top of your head. It's just you're looking for the midway point because they're on opposite ends, directly opposite ends. So you just need to just do the midpoint formula.
Exactly.
Is exactly what he circled right there for each variable, and then
Yeah.
you should be.
So just to be a tiny bit more explicit, right? We would say that x naught is equal to what is it? P naught plus, or I guess this is P in the x component and Q in the x component over 2. And similarly for y and z. Okay. Shall we move on to the problems that more involve vectors? Distance from A to B is 20. What's up?
Sounds good to me.
Okay. By the way, did any of you have any questions on the homework? I think there was one problem on the homework that was a little bit nifty. It was the one where it was asking you about the what is it, 5u plus 4w, when it didn't give you u and w explicitly, but gave you u squared and v squared and I think u dot v. Did you all get this one? Do you remember seeing this problem?
I don't think I did. I don't remember that one.
Okay.
I don't believe I got it either.
Oh, wait a
It
minute.
may have.
Do these
I think
problems
the
vary by class, you
problems
think?
are different. Probably, yeah.
Okay. I think
And
that
I know
one.
the
Mhm.
specific numbers vary by person as well.
Right, gotcha. Well, that problem, yeah, so maybe this is a really good problem to talk about because I would say this was probably the maybe slightly tricky problem on that last set. But I think exactly what did it give you? It told you like u is equal to, I'm going to make up numbers here. Let's say this is 5 and v is equal to 10 and u dot v is equal to, I don't know, 6. How would you find a combination of 5u plus 4w? Any ideas? It's a little bit not obvious, right? The first thing I think most students want to do is just say, okay, I really want to just hope that this is equal to 5. I'm really hoping that the magnitude of the sum is the sum of the magnitudes, and students will do something like this. But this will give you a big fat 0 on the test because it's possible that u and w are kind of in opposite directions, and you get some cancellations, right? Whereas this comes out to be a large positive number because you're pulling out the magnitudes. It's totally possible that u and w totally cancel out to like end up with 0. You see what I mean? So that's not the approach you want to do. This is bad. So how would you do this instead? If all that you know are the individual magnitudes in the dot product, do you have any ideas?
I was thinking, I'm not sure, but it could be like the square root of 25 u, or like you would separate it into u1, u2, and u3, and w1, w2, w3 for the components of the vector, and then do like the square root of 25 u1
This,
plus 16 w1, and then like basically add them as the components without actually plugging in numbers.
I see. So I think it's going to be the wrong direction in this problem to try to break it down to be even more granular, um, on the level of the components, because, well, it's not necessarily a bad approach. I just don't think it's going to work out in a productive direction. At least not what I want to think of. Like trying to make it more concrete is not really going to help you when you know nothing about the directions themselves, or when you don't know any of the individual components themselves. All you know is sort of their relations of the sort of their values of their dot products and magnitudes, right? It's like from a problem solving perspective, you're trying to make it more concrete, but all we have are sort of abstract values. So I don't know how to make that approach work out, but I think it's a pretty reasonable guess. Do we have any other ideas for how to approach this? I think thinking about squares and square roots is really productive, though. And I'll go ahead and make the suggestion. The suggestion I have is instead of trying to figure out the magnitude directly, let's figure out what the magnitude square is. And this is just equal to 5u plus 4w dotted with itself. But oh, wait, we can use, what do you call it, distributivity. We can essentially FOIL these out in just the way that we'd like. And everything we have left is going to be in terms of u.u, w.w, or u.w. And we have all of that information given to us from the problem. So I would maybe encourage you to play through the rest of this problem yourself. But can you see this problem solving idea where even though we did not have a couple of pieces of information that might make it kind of uncomfortable to think about, it turns out that we didn't actually need those granular pieces, those individual components of u and v. I'm sorry,
Could you
did I
explain why
use,
you squared it?
huh?
Could you explain why you squared it?
Yeah,
Chose to
it's
square
literally
it?
a problem solving trick. By the way, I'm really silly, and I used u and v up here and u and w down here, but let's just keep this consistent, okay? Sorry. But yeah, why did I square it? It's literally just a trick. Because if I didn't square it and was just talking about 5u plus 4v, this would require me to think about the square root of 5u in the x component minus 4v in the x component squared. And this is already stuff that I have no idea how to think about, right? This is already stuff that I have no idea how to argue about. But the square is almost like a trick I pulled out of a hat, but it's not really an unfair trick because it's almost like one of the very most basic common tricks in multivariable calculus that you might want to carry through with you is, sometimes it's much easier to look at the square of a magnitude than the magnitude itself, right? So like if I was a student, back, this might not be the first thing I'd think of. I'd probably have to play around for a while, but this is maybe you could call it a semi-inspired trick to solve problems like these. Okay. I hope that explanation makes sense. Is everyone okay with this? Yeah. It's a shame that the homework sets are different. I think that was a pretty good problem, and it took me a moment to think about it. But I guess without further ado, we'll continue going over review. So what is it? They give us the points A, B, V, and W. And they say write an equation that expresses each of the following relationships. So the distance from A is saying the distance from A to B is 20. Okay. So that's basically just our distance formula. Yeah. That's basically saying for R is equal to the square root of, AX minus BX squared plus blah, blah, blah. Same thing for Y and Z. It's basically saying that this is, it's basically saying this thing is 20. And you ought to be able to just plug in, the values of A and B. I don't think there's too much else to say about that one. Would anybody like me to do it explicitly, or should I move on? Like, don't get too distracted by the fact that A and B still have an unknown in them. For the purposes of part A, it's not like it's asking you to solve anything. It's basically just saying, hey, go ahead and just, plug these values into the distance formula if need be. Maybe I should call the distance formula D is equal to this instead. Okay. If there are no, what questions do you have for me on that one? If none, I'll move on. So V and W are parallel. Okay. Ideas here. How would you approach this? For
the parallel property, I think they just need constant, some constant scalar hold the relationship between them.
Yeah. No, I think that's pretty reasonable. That one gets into a little bit ambiguous because it requires you to introduce some k, but you know what? I think that's reasonable. It's not what I had in mind personally, but I think it's totally reasonable. So basically, the suggestion is to say that v is equal to kw, and when you write it this way, you always have to specify for non-zero scalar k. Yeah, but that's pretty cool. Perfectly valid solution. Does anyone have other ideas as well? There should be at least two other ideas that should come to mind, based on the stuff that was introduced at the start of this course. Any suggestions? I'll start giving out hints otherwise. How would you do this with the dot product? How would you express this using the dot product? Any takers? Any brave volunteers? What's up?
Oh no, I did it the same way you did. So I actually just used a scalar because that's how I kind of like visualize it in my head.
Mm-hmm. That's perfectly reasonable. I'll give you a hint with dot product. Right. So remember that dot product. I'm sure you've seen the official definition of it and whatnot, but dot product is sort of an idea of measuring the similarity between two vectors. And in some sense, a dot product is maximized when the two vectors are as similar as they can be, which means they're parallel in the same direction, or it's maximized but negative when they're in the same direction but opposite. So with this in mind, how can you express to me that V and W are parallel using a dot product? Brave volunteers?
Well, if they're parallel, means they have everything in common.
Right?
So
Express that using an equal sign.
equals one. I'm not.
Huh? Equals 1?
No,
No, I think that's productive. I think that's a productive direction to go down. Remember, what is this? V dot W. What the magnitude is equal to V W. God, I always forget. It's cosine theta, right? So how do you express to me? Basically, this is saying this is equal when, when theta is equal to 0, which is the same thing as when cosine is equal to 1. And oh, look, this is a perfectly valid equation right here. This is what first came to mind for me. Basically, that the magnitude of V dot W is equal to the magnitude of V times the magnitude of W. And if you want to rewrite it, I think in the way that the student was suggesting, you could rewrite it as something like this. Perfectly valid as well. Okay. So that's how I would do this with a dot product. Any other suggestions? I can think of at least one other way to do this. We've talked about the dot product. Does anybody have any ideas for the cross product?
Wouldn't the cross product of the two be equal to 0?
It would be. Very good. You got it. So yeah, V cross W equal to a big fat 0. And okay, if you're being really if you're being really painstaking about the notation, you would probably put vectors on top of all of them, or you would say V cross W, the magnitude, is equal to 0. But yeah, you got it. Very good. So that's at least 3 ways to answer that question. And on a test, we probably only got to know one, but I think it's very useful to talk about the relationships between, what do you call it? Yeah, the relationship between dot and cross product. So with that in mind, how would you explain part C to me? How many ways can we think of part C? Where express that V and W are perpendicular. How would you do this with a dot product?
For this one, would the dot product have to be 0?
It
Because
would
isn't
be.
it when data is pi over 2,
Exactly.
the dot product is 0, so that would give you 2 perpendicular vectors.
Yep, you're all saying very good stuff. Yeah, so VW, what is this? God, I always need a cosine theta. So this is basically saying when theta is equal to pi over 2, then this entire thing is equal to 0. And to express that, that's just saying, if you have vectors V and W and there's an angle between them of a right angle, well, yeah, that's why theta is equal to 90. You see why this all works out, right? You plug this in here, you end up getting a 0, and the dot product is 0 correspondingly. And to express this with cross product, how would you do it? It's very similar to part B's dot product, but the idea is that V cross W is equal to the magnitude of V times the magnitude of W. Because remember that there was this extra sine theta term, but when it's orthogonal, then this becomes pi over 2, and this entire thing just becomes 1, and you can ignore it. So this is the expression that tells you V and W are perpendicular. Pretty good, right? I hope that if any of you had one answer in mind for one of these, I hope that you learned something, or maybe expanded the way you think a little bit, in that realizing that there are multiple options. Okay, vector W is twice as long as vector V and points in the opposite direction. I hope that one's not too bad. Should I go over this one, or should I just ask someone to do it? Right, so V...
Well, for that one, it would have to just be a negative scalar, right?
Exactly.
By scalar being 2, because the negative points in the other direction, and the scalar makes it twice as long.
Yeah, so you just gotta, for problems like these, you always gotta make sure which one's which, but it's saying that vector W is twice as long as vector V and points in the opposite direction. So based on that reading, the -2's gotta go in front of the V. But yeah, that's the exact same idea. right? So just visualizing it, because I always like to visualize things. That's basically saying if this is V, then W has the exact same magnitude, but doubled in the opposite direction. Okay, so if you start at the point A and move along the vector V, you end up at point B. Okay, A and B. How would you express this? Yeah, I find these questions kind of grating, to be honest. I almost feel like they're kind of, how do you put it? They're multivariable calculus is a class where things don't really start coming together until the end of the semester. And at the start of semester, they're just teaching you all these like computational obnoxious things, but I expect it to pick up pretty soon once you tackle derivatives. So if you're bored and finding things easy, don't worry, it'll get much more painful soon. But any suggestions for this one?
I made AB a vector by subtracting subtracting A from B and then setting that equal to V.
B minus A, and you're setting that equal to A. Sorry, what exactly are you setting equal to?
I set it equal to V. Just because that it says that if you move along vector V, you end up at the point B.
Oh, I see. Yeah, that seems perfectly reasonable. B minus A is equal to V. Sure. I thought of it as A plus V is equal to B, and I'll just be able to see why this is exactly the same thing. Yeah, I don't know. I don't think these problems were, well, the parallel and perpendicular ones, I hope that you got a little bit out of and thinking about it different ways, but the other ones feel kind of grating. But now we move on to the good stuff, or at least slightly takes slightly more elbow grease, in that it's asking us to find what is this, the line through 3 comma 4 comma 0 and 2 comma negative 1 comma 2. So do we have any suggestions for this one? It's I think it's actually pretty similar to the one we just did, right? You have 2 points, but this time around you want to parameterize something using a parameter t. So parameter t. And the idea is, if you just draw this out, let's call this one A and this one B. The way I would probably, so if this is A and this is B, and there's some vector, let's call it V, right? You could probably just describe this line as A plus V T. Sorry, what do you have to set this equal to? I guess RT is equal to A plus VT. And I'm leaving it kind of abstract because I don't feel like it's the most interesting problem in the world. But similar to as before, V is going to be B minus A, and T is going to be our arbitrary parameter. A is going to be just the given one. And R of T is usually called the position function. Does this one make sense, or should I spend a little bit more time on it? Do you all understand why we had to introduce the arbitrary parameter T?
Can you explain it your way, because it's good to hear?
Yeah. So like, how would you do this problem if you didn't introduce a variable T, right? It's kind of like, how do you put it? If this was one-dimensional calculus, right? If this was one-dimensional calculus and you had 2 points, you could, get the slope between them, right? Or you could talk about a vector between them. But in order to actually turn it into a, in order to actually turn it into a function, right? We want to basically, if your goal is to find the function f of x that describes this line, well, like you said it right there, right? You kind of need to introduce the idea of an x. And that's exactly what we're doing right here, but instead of an x, it's a t. Do you see what we're getting at?
Mm-hmm.
Yeah, it's this is almost like one of those, I wouldn't necessarily call it convention, but it's sort of just understanding that what you're being asked to do is to find a when it says that's find an equation, it means sort of find a function that describes this. Because the point is, if you didn't have some arbitrary vector x, I could I could describe the vector between this, but that's a vector and not the line that we're actually being able to find, right? In order to define like a set of infinite points, which is a line, you kind of need that independent variable x to describe all the possible points along the line.
Yeah, that makes sense.
Yeah.
You gotta generalize.
Yeah, I really hated back when I was, finishing high school, getting into college. I really hated parameters and just didn't want anything to do with them. But they're kind of just your independent variable that you got to use for problems like these.
Could you explain how you constructed the equation again? I didn't really understand that part.
Yeah,
The
sure
R of
thing.
t.
So this is vector A, and this is vector B, right? So I'm basically saying, excuse me, this is A and this is B, and I'm thinking about just creating a vector between them. And this vector kind of like coincides with this line that we're being asked to find, right? So I guess the point that I'm making here is, if ultimately we're trying to find an equation for the line, it really helps to figure out what this vector information is, because it kind of tells you the direction. It kind of gives you a little bit of direction information, right? And maybe let's put it this way. When in single variable calculus, you like to say f of x is equal to mx plus b, right? The m is sort of the direction information. That's sort of the slope information. And it's one of the first things you would try to find if you were to ask, if you were being asked to find a line between 2 points, right? So similarly, because we wanted to find an m in one-dimensional calculus, now we want to find kind of like a v in multi-dimension functions. Do you see what I mean?
Yeah.
Yeah.
I see
So
that.
this gives you the direction, and you kind of need like this arbitrary variable that kind of like slides how far along here you go. Or keep in mind, it could be negative and in the opposite direction as well. But once you have that, this equation here is literally almost identical to this equation right here. You see the correspondence between single variable and multivariable functions? Well, you couldn't even call this multivariable. It's just in a higher dimensional space.
Yeah, it's just a different sense of the equation.
Yeah, I mean, hopefully, I like that explanation. Hopefully, seeing the connection back to something from high school makes the motivation clear, at least. Okay. Are you ready to talk about how to find planes in general? This feels like it's the first, what's up?
I was just saying yes since nobody said it.
Oh yeah, okay. Yeah. So how I guess I want to know where you all are at. If you were being put on the spot, like qualitatively, could you describe how you would go about finding a plane? Equation of a plane?
Probably not.
Probably not.
I definitely could not.
Definitely could not. Okay.
To my notes.
Yeah, this is tough. And I always find myself having to look it up every time. Or rather, I know the process by heart, but having to justify it again either takes me a little while of messing around with pencil and paper or just looking it up. But I'll quickly run through the cliff notes, so to speak, of the justification, and also show you the quick and simple process of how to do it. Right? There's theory and then there's practice, and I'll show you both. But the idea here, okay, my screen froze for a second. Okay, so I always like going back to the one-dimensional analogy from high school, but I will assert without proof that given 2 points, there's a unique line that runs through them. Hopefully you all believe this from high school, right? Sorry, the silence makes it uncanny sometimes. I hope that this is a universal yes rather than a universal no. But
it makes sense.
Yeah.
It's a yes.
The idea behind planes, so let me tell you this. A plane is just a higher dimensional line. They're the equivalent, they're both the sort of linear function, linear in x and y functions at their respective dimension, whereas a line is going to be in 2D. Like a line can reside in higher dimensions as well, but a line starts to make sense when you're at least in 2 dimensions, right? I guess it makes sense in one dimension as well, but ignore that. But the idea is a plane doesn't start making sense until you get to 3D. Yeah. And the idea here is that a plane is uniquely specified by 3 points, whereas a line was uniquely specified by 2 points. And you can kind of see the correspondence here, the beginnings of a pattern. And as it turns out, if you learn in linear algebra, this pattern holds true. In a 4-dimensional space, a 4-dimensional hyperplane is going to be uniquely specified by 4 separate points. And just without proving it for a second, can you just like mentally picture to yourself that, if you just had 3 points in space in your room, there is guaranteed to be one infinite plane that runs through them and only one? Can you picture that? Is this a believable claim? Like,
Yeah.
Yes.
Yeah, okay, good. No, so your spatial intuition is hopefully makes sense. But that's something that I can't really that kind of intuition you just have to like literally play around with your hands a little bit and just argue, just intuit to yourself that if you have 3 points in space, only one plane can go through all of them. I'm sure there's a YouTube video somewhere that maybe gives you a little bit more visualization, but I don't have that on hand right now. But the idea here being is we have these 3 points, and the process for it goes something like this. So one of the biggest things we want to do is WTF means want to find a normal vector. And the reason we want to find a normal vector, so if this is your X, Y, and Z planes, doesn't really matter that it's neat or messy, right? And this is your origin. The idea is basically, if you can give me a vector on this plane, and if you can also give me a normal vector, that's basically all you need to specify. That's basically all you need to specify the equation of a plane, because you can basically say if this is P and this is P naught, and this is R minus R naught. Do they have a better name for this? Excuse me. R minus R naught. The equation of a plane is essentially saying n times R minus R naught is equal to 0. Because by definition, the normal vector to a plane is one that is perpendicular to the plane, and that means it's perpendicular to every single vector inside that plane, which is just another way of saying if you can find me the normal vector, and if you can find me any vector on that plane, well, we can just take a dot product of the two, set that equal to 0, and this is our equation of the plane. Does this motivation make sense so far? If we can find all these things, we're done. Does that make sense?
Could you repeat it again?
Sure.
Just the different components, how you found that.
So this is the normal vector. So I don't know how to, so let's say that R and R naught are given to me so far, right? The problem gives me some of the stuff. If I can just find a normal vector, then I should be golden. Because, how do I say it? By definition, the normal vector is perpendicular. This little square right here means a 90-degree angle. It's perpendicular to the plane. And the normal being perpendicular to the plane means that it's perpendicular to every single vector in the plane, including this R minus R naught vector. Does that make sense? So that's why we can say n dot R minus R naught is equal to 0, because by construction, the normal vector is perpendicular to every single one of these vectors. That was a mouthful, but does that intuition make sense?
Yeah, you find a vector on the plane, and then you find the normal vector, which by logic, the normal vector is perpendicular to every vector on the plane.
Not even by logic, just by definition. By definition, really, or construction. But so then, okay, you've noticed that I've said that this requires us knowing either 2 points or one vector. But earlier I said we needed 3 points, right? And the reason we need a couple more points is to find the normal vector itself, right? So I'm claiming to you that having 3 points is sufficient to find a normal vector. So 3 separate points, I'm going to call it 3 unique points, I'm going to use an arrow to say will give you a normal vector. Can anybody think of the process to do this? Can anyone figure out, if I give you 3 points, can anybody figure out how to get a normal vector out of that? I'm going to draw this out a little bit, okay? And at any time, if you get the idea, shout it out. So this is a plane, and this is our 3 dots within the plane, right? Let's call these points R, R naught, maybe R1. What if I draw some lines between them? What if I draw some vectors between them? Can you get me a normal vector now?
If you find the 2 vectors and then take the cross product, it should give you the vector that's perpendicular to them.
Exactly. Cross product. That's the key. Cross product.
Why would that work?
The cross product, by construction, by definition, takes 2 vectors, and as long as they're not parallel to each other, it spits out a perpendicular vector.
Oh, okay.
Yeah, it's literally the construction. It's the construction of the cross product that was basically built just for this. But yeah, you got it exactly right. So basically this is saying, I don't know, what do you want to call this? Vector V, and maybe call this one vector W. You find V and W by just taking any, just taking the 3 points and, maybe choosing R as like a pivot point, and then finding R naught minus R, and then R1 minus R. This is simple, right? This is just finding 2 vectors out of 3 points. Hopefully shouldn't be too hard. But then taking the cross product is going to construct the vector n, right? And this is going to be a perfectly, hopefully a perfectly valid cross product, which is going to be, a vector with a couple of components. So what did the problem say? 3, 4, 0, and 2, -1, 2, and 5, 0, 1. Right? Take any of the 2, figure out your vectors, and get me a cross product. And once you have that cross product, all you have to do, let's go back. Sorry, that cross product is the normal vector. And then just take any of the 2 points to get a vector that lies in the plane, dot them together, and you're done. You're done. Sorry, let me address my notation a little bit. This R is sort of our choice of independent variables, kind of like X, Y, and Z. Whereas this R naught is kind of our X naught, Y naught, and Z naught, right? These are kind of like actual things that you plug in, constants, whereas these are your variables. So maybe I should just go through explicitly with the example. Generally speaking, how are you feeling about this conceptually?
Pretty clear.
Pretty clear. Good. Wow, I realized that would actually require me to take a cross product, and suddenly I'm very unmotivated. It's been years since I actually want to calculate these by hand. Yeah, so what does this look like? Basically, I'm going to say V is equal to, I don't know, one of these minus the other. So like 2 minus 3 is -1, -5, 2. And W, so I'm, 2 minus, so this is 1, 2, and 3. This is 2 minus 1, and then 3 minus 1 is 5 minus 3 is 2, -4, and 1. So then I'm going to cross V and W together. And I'm not going to do the calculation. I don't think it's worth any of our times. But this is going to be some perfectly genuine vector. I'm going to make up some random numbers, okay? I'm going to make up some random numbers just to... Wow, my screen is really lagging right now. Sorry. I'm going to make up some random numbers, 10, 11, and 12, to emphasize that these are like straight up numbers rather than variables. But I'm going to say calculate this yourself. Okay, so then this is our normal vector. And the idea is, okay, at this point, all we have to do is take n and dot that with, sort of our variable r minus r naught. And this r naught can be any of our points that were given, such as 3, 4, 0. My screen is lagging really bad right now. Hopefully it's not too terrible for you all. But yeah, I might have to end the session soon and restart my computer. And what did you say this was? This was 10, 11, and 12. Started with this. So at this point, you just do this and set it equal to 0. And that's your equation of a plane right then and there. That's the process. This is a complete answer. Although usually, just for the sake of posterity, you usually want to move some of the terms to the other side. Gosh, this screen is so bad. So this looks like 10x plus 11y plus 12z is equal to, well, the other dot product becomes 10 times 3 plus 11 times 4 plus 12 times 0. Yeah.
It wouldn't matter, like any order of the vectors, right? They would all like an equal equation, right?
Yeah, no, you could have. If what you're asking is like, if you wanted to do r naught minus r, that would have been perfectly fine too. Because if you did r naught minus r, that's basically just multiplying through this equation by -1 on both sides, right? That's just switching the order of subtraction. So yeah, that's perfectly valid.
Okay.
Yeah. So again, the 10, 11, and 12 are, random numbers I made up. You need to calculate this for yourself. But that's the idea. So hopefully not too bad.
No, that was a very helpful explanation.
Thank you. That's what I try to be here for. I also kind of get the feeling that, I guess, low fare sessions like this, I hope, are kind of more educationally like easier to grasp than I don't know, whiteboard or blackboard lectures. But basically the idea is I'm just a hobbyist. I last quarter I was doing last minute exam reviews just with the students because they seemed like they were all in panic mode. Last semester the exam scores were all in like the 50s if I remember correctly, and the students were having a really rough time of the class. I came in somewhere around the halfway point.
For 10C or for physics?
For 10C. Yeah, they told me that the first exam scores were in like the 50s, 54, 55.
But it was with a different professor.
Yes, that's true. But yeah.
Yes, our exams are not curved.
Your exams are not curved?
No.
Okay. Yeah. I remember when I took multivariable calculus, the class averages were also about there. We had a professor who really had high expectations for us.
Well, I had the same professor that we have right now last for 10B, and the first exam is relative to the rest. I mean, but she is she's predictable. It's just she's formal about her stuff, which is good in a sense.
Okay, sure. Yeah. So then the last question for this part is basically saying, okay, so just sorry, going back for a second, I just wanted to reiterate that point I made at the start, where we said that a plane is uniquely determined by 3 points. And the reason why we say that is because if we didn't have the third point, if we only had 2 points, right, we could have any number of normal vectors that's perpendicular to just this one thing, right? We don't have 2 vectors to do a cross product, so a unique normal vector, or at least a unique direction, can't be determined. So do you kind of see why having 3 points is, well, I don't know if quite necessary, but like why it's sufficient, and having only 2 points is not? Because, you could have a normal vector like going straight up, or you could have one like kind of at an angle over here, or you could have one, you could basically have an entire wheel of normal vectors if all you had were 2 points to go on. That's why it's insufficient. But the next part is basically changing this around on us a little bit. They're giving us 1 point, and they're also giving us a line. RT is equal to t plus 1, 2, and what is that, like 4t minus 3? So let's just visualize what this is saying. This is saying that there's a plane right here, and there's a point, and there's a line somewhere in here. I guess I'll draw it both directions to indicate that it's a line. And this is saying plane containing the point. So, this entire line is contained by the plane, which is another way of saying every single point on this line, point, is contained inside the plane. So given this, how would you approach it? We can really reuse the method of the last problem. We just have to sort of massage it and convince ourselves that it's a similar problem. How would you think about it? Remember, if we can get 3 unique points, we are done. So how would you get 3 unique points out of this?
Well, we also want to know, do we not care about the normal vector anymore?
We do. I would say getting a normal vector would be really nice. But last time we used the 3 points to get to a normal vector, right?
But the normal vector, I thought, was just the coefficient. Or I thought the normal vector was somehow contained in the R of t. Can't we just say that?
Oh, no, sorry. R of t is not, this is not a normal vector.
Oh, yeah.
Yeah, a normal vector is something perpendicular to the plane. This line is contained by and thus parallel to the plane.
Yes. Yeah, that makes sense.
Yeah. But I'm really happy you asked, because I think that's a very reasonable thing to get, because they're both kind of like lines, right? Where one's a vector and one's a line. That's a very easy mix-up, and I'm sure I made that a bunch when I was a student as well. So I'm happy you suggested that, but just make sure not to do that on an exam.
Can you just break down the R of t stuff again? Because I know that like the coefficients on t are supposed to mean stuff.
Yes. Exactly. The idea is just choose any 2 values you want for t to get 2 separate points on the line. And then that is your 3 points right there. And you can just use the exact same process from last problem. I should have said something much earlier. A plane is determined uniquely by 3 non-collinear points. Non-collinear means they're not all 3 in a row. Because if all 3 points are in a row, any number of planes you can imagine like sort of, any number of planes could contain this line just by rotating the plane around. Yeah. Sorry, I feel really silly that I didn't mention this word explicitly earlier. But the point is, this problem gives us a line which is a ton of different points, right? A ton of different points. We can choose any 2 of those points, and we can just choose take the other one they give us in order to have 3 separate points, and then it becomes the exact same problem as part B. You see that?
So to clarify, we just substitute in an arbitrary value for t.
Yeah, 2 arbitrary values. I would say t is equal to 0 and t is equal to 1. So just see R of 0 is equal to 1, 2, and -3. And R of 1 is, you could choose like R of 100, R of 1,000, R of 12, doesn't matter. I'm just choosing the ones that I think are simplest. Right? And these are 2 perfectly genuine points that are in the plane. And yeah, that should be all that you need. I guess it's also good to make sure, just as a sanity check, that this point is not actually in this line. If this point was on this line, then it would be a trick question, because you could not uniquely determine a plane. But you can tell right away that the point is not on the line because the 4 and the 2 do not match up. But yeah, I think that answers all the questions that are present about the planes. Do you have any questions for me? Is there anything I could have explained better?
So could we have found one of the points as 1, 2, -3, because it's like it's t and then I don't know how to phrase it, but it's like what is after the t that comes. It's a point.
Sorry, I'm a little bit confused. Can you? Reword your
Okay,
question.
so in the equation, it's t plus 1, comma 2, comma 4, t minus 3, right?
Hmm.
So in other equations before, I think we've been able to identify the points as being like 1, 2, and -3. Um, does that work in this case or no?
So, I mean, when I plug in t is equal to 0, that's saying that the point 1, 2, and -3 is a point on the
Sorry,
line and on the plane.
yeah, sorry about that. I didn't even realize. I was so focused on the question that I didn't realize the answer was right there.
Oh, no worries. But are you, is that a satisfactory answer? Or is your
Yes, thank
confusion
you.
addressed? Okay, great. Yeah, anything else there to say about planes? Like, I feel like this exam coming up, there's just not a lot of information that's being presented. Of course, for one, there's literally zero calculus that we've done so far, right? We haven't looked at anything remotely similar to a derivative. They're just kind of introducing the groundwork, the basic tools. Whereas you spent probably the first 10, 11, 12 years of your school life learning all the stuff leading up to calculus. This is, or single variable calculus. This is presenting all the tools you need for multivariable calculus in like a month. But the motivation behind the dot product and the cross product is to come up with a equivalent of multiplication in higher dimensions. Because addition and subtraction work just fine, right? Addition and subtraction between vectors um, is basically just exactly as you would expect. Combine the components piecewise. But when it comes to multiplication, they decided that component-wise multiplication doesn't make a lot of sense, and that they needed to come up with these definitions of dot and cross products that turn out to be very, very useful basically everywhere down the line. Sorry, that was my little math motivational rant. Want to look at the last problem about the force diagram?
Okay, I got
No.
you. Thank you.
Okay, we could totally do this problem. Okay, so that's the just intro physics kind of way to do it. We could totally do this problem via projection if we wanted to, now that I think about it. But if we really wanted to project it, we would project F onto the parallel angle, right? We would project it onto the parallel vector. What do we want to call that? Like vector, maybe V? So the parallel vector is V. Yeah. And so if we project it onto the vector V, this just becomes F dot V over, I'm going off the formula off the top of my head, but it should look something like this, right? So force parallel is equal to this. Yeah, I guess that's a simpler way to do it. I guess because I always did this problem in physics, my first instinct is geometry rather than vector projection. But this seems like a perfectly valid solution as well. And then force perpendicular would be equal to, is it force minus force parallel? Yeah. Because the idea is the parallel and perpendicular components have got to add up to be the original one. Right, so just as a reminder, force parallel plus force perpendicular is equal to the force itself. So all I'm doing is subtracting this to the other side. And this is the complement, and this is the projection. So that should solve that problem just fine.
Why is the magnitude of V squared on the bottom? Because she had done this problem before, like for one of the worksheets we had, but
Yeah,
it was the magnitude of F dot V over the magnitude of V.
F dot V over the magnitude of V. So that's just, yeah, no, what you're saying right there is F dot V. That's over magnitude of V, right? So this right here is just the magnitude. And what I'm doing is I'm also multiplying it by V over itself in order to isolate out the unit vector. You see that?
Oh, I see.
Yeah,
Yeah, thank you.
of course. By the way, do you all know the explanation behind vector projection off the top of your heads? I heard a lot of students complaining or saying that it was kind of hard and confusing, but it shouldn't be so bad. I think it's just a 2 or 3 minute explanation. Are you all comfortable with it?
I'm willing to hear your explanation.
Sure. I mean, it's really nothing particularly special. I just like putting it in terms of um, everyday objects, really. So, if you had some vector x and some vector y, and you want to find the projection of x onto y, right? I want to think of this almost like as an everyday example outside, where y is the ground, and this is maybe your house, and you're trying to do something, get up to your house on a roof, and maybe x is like a beam or a rafter that you're laying against the side of your wall, right? And the idea behind vector projection is basically the sunlight is coming down from the sky in perfectly perpendicular beams that are perfectly perpendicular to the ground. And the vector projection is literally the shadow projected by the shadow projected or cast by x. That's what a projection is. That's why we call it a projection. And okay, so basically they just want to find the projection as a vector, right? Treat the shadow as a vector. So the idea behind this is basically if only we could figure out what the heck the angle theta is, we would be done, because the magnitude of this thing is just x, magnitude of x cosine theta, right? That's just basic trig. If we could just find this, we would be in great shape. So this is the magnitude of projection or shadow. So, okay, but the issue is we don't know exactly what theta are, but what information we do know are x and y. And one of the things available to us is just x dot y. So let's just write out what we know about x dot y. This is equal to magnitude of x, magnitude of y, and cosine theta. And it's like, oh heck, the x and the cosine theta looks a lot alike, what we're trying to find. So the idea is, why don't we just move y to the other side by division? So this turns into x dot y. My screen's getting really laggy again, so hopefully it doesn't mess up too hard. But this is the magnitude right here, x dot y over y, right? That's literally equal to x cos theta. And all we do after that is we just slap on a y unit vector by multiplying y and dividing by its magnitude. It just, we have the magnitude already, and now we have the direction. So this is magnitude, and this is the direction coordinate. And this is your expression for the projection right here. Make sense? This is one of those things where like the final equation is kind of like messy and just looks like a lot of things coming together. But each individual step is really just a high school trick. Do you see that?
Yeah, is that actually where vector projection comes from historically? Do you know?
Uh,
Like,
Sorry, it's a little bit hard to hear your microphone, but this or something like this is probably the motivation for vector projection. It's like the projection is literally basically a shadow cast by, you can think of it as a shadow cast by sunlight beams that are by construction perpendicular to your ground.
yeah, that was really helpful.
Oh,
Thank you.
awesome. Thank you. I'm glad. Here's the thing that I don't ever want to come off as patronizing or condescending when I come up with these like everyday examples. But I hope that they can make things just really, really intuitive, But like I don't ever want to talk down to students, but I think, I think they would have helped me understand it when I was a student. And I remember that when I was in multivariable calculus, this was the very first thing that was like, wait, what the heck was that? Because my high school fundamentals were kind of weak at the time.
Yeah, totally. I agree that helping students have intuitions would be more central.
Yeah. And I think with textbooks, they probably present it in a kind of dry format. And you end up maybe understanding each step, but just get to this like mosh pit of X's and Y's at the end and just wonder what the heck you're looking at, right? But like one of the helpful things to think about it is, instead of thinking about it as like y squared down here, think about it as one y being associated with a magnitude and the other y being associated with a direction. And you can kind of remind yourself why these are separate components. Or you can kind of like mentally isolate them out in your head to remember that like one is the magnitude and one is the direction.
Right.
Yeah. Okie. Well, I think that's pretty much all the material I wanted to cover. What questions are
Just
there on the floor?
I had one just to clarify. So the ultimate formula we came up with, that's the standard formula for
Yep.
vector
This
projection.
is exactly what you're going to find in your textbook. Yes.
That's what we got to find. Okay, thank you.
So it's just going to look like x dot y over y squared times y. Yeah.
What's your YouTube channel?
Oh, it's just called VTutor Live. Yeah, I this semester I'm trying things out a different way. Last semester was my first time doing it. This time around, I'm going to try to record things and put them onto YouTube. For example, this lecture, in case anyone who wants to review it or anyone who was really busy and couldn't make it, to hopefully, hopefully get in on the explanations. But yeah, I'm basically I'm a software engineer who misses math a lot, and I have some free time, and I try to help out with students who are probably struggling more than usual in the pandemic. And that's about it. These sessions are always free. It's a hobby for me. But you can always ping me if you have questions, and I will try my best to help. I should always mention that I take academic honesty seriously, and I will never help with a quiz or a test. And when I explain homework problems, I explain it so that you can solve it for yourself. I'm not trying to give out answers. But yeah, that's the spiel.
Thank you. Really appreciate it.
Sure. Let me know if there are any other questions remaining. Otherwise, I hope you all enjoy your evenings.
I have a question. Back to 3B.
Yeah, let's take a look.
I actually went back and I did the cross product. But I just had a question about like moving. It's XYZ dot one of the points, right? And then that is also multiplied by
Sorry,
the
hang on. Sorry. 3B is the one about sorry, getting the points to turn into a plane, right?
yes,
Okay,
yeah.
sorry. Can you re-explain from the start? I was looking at 2B instead and got lost.
Oh, yeah. So the vector, the normal vector that I found after finding the cross product was 3, 5, 14.
Okay, I'll take your word for it. 3,
Um
5, 14.
yeah. And then so we're supposed to
That's right, by the
multiply
way.
that. Okay, great.
Yeah.
That's good.
Here's a hack that I should have mentioned earlier, and if I was more fresh on multivariable calculus, I would have. But look at the answer. You see how the answer is 3x plus 5y plus 14z
Yeah.
is equal to 29? Oh, what do you
Yeah, okay,
know?
that's
Like, what are the
vector.
odds of that, right?
Yeah.
Yes.
Okay, yeah, that's what I was,
Yeah.
asking earlier with that other problem when it just turned out that if you plugged in 0, it would have given you the same thing. Um, anyways,
Sorry,
sorry.
what's the other
So
problem
I'm
you were
just
talking about?
wondering, um never mind. I'm just
Sure.
confused about, for this part, why it's positive 29 instead of negative 29. Because if you had moved it over to the other side, um, does sign just not
This might just be a computational error on somewhere or another. I mean, I can explicitly do this out. Do you happen to know which point they plugged in? Was this 340?
Oh, wait, does that say XYZ minus 340?
Uh,
Inside of the
yes, it does. This is a
parentheses?
minus right here.
Oh, okay, that's where I went wrong.
Yeah.
Okay.
By the way,
Alright.
if the thing I was mentioning earlier is, if once you when I was doing these problems and got comfortable, I wasn't going through the entire process of the theory every single time to remember why the normal vector was important, right? I would just do the process. And the really, really quick and fast way to do this, if I remember correctly, was like x minus x naught. Uh, what was it like? N, sorry, nx x minus x naught plus ny y minus y naught plus nz z minus z naught is equal to 0. And once you have the normal vector, you literally just plug in all of these. And then you plug in one of the points like 3, 4, 0 into x naught, y naught, and z naught. And remember, regular x, y, and z are just your independent variables. And that's it. You can do a problem like this in like basically as fast as it takes you to find a normal vector. You could do this problem in less than a minute if you're confident in your calculations. And
Okay,
if
that
something
makes
like
sense.
this is the hardest question than the midterm so far, I have a feeling that all of you who are studying relatively early are hopefully going to crush it.
Yeah. All right. Thank you so much.
Yeah, sure thing. Yep. And the other thing was, uh, last
Are you
semester last semester I was basically only helping out before exams. But this semester I plan to do a session like this basically every week and going over homework problems and stuff like that. So stay tuned.